All right, guys, so I'm just going to finish up here with the examples that we had on the slideshow from today. Examples 1 and 2, I'm going to post on Classroom, okay, so you can see them worked out. You can also see how Delta Math worked them out is a little bit different than I did. Remember, I used dy dx the whole time instead of y prime. And, you know, you could use y prime, but I don't recommend it. Just stick with dy dx, okay? But again, the same idea is, we have the same idea here, which is take the derivative of everything, and if you see a term with y, include dy dx, and then solve for dy dx, okay? So I did those first two examples there, right? Let's do this, this next one here. Okay, so this is example 3, kind of the same way. So remember, we're going to take the derivative of both sides, right? So we're going to take the derivative of what's on the left, okay? And we're going to take the derivative of what's on the right. Okay. Now you see a lot of y's here, so you're going to have a lot of dy dx's, right? So first, the derivative of -5 is 0, so that's nice. I don't need to worry about that. The derivative of 3y to the third is 9y squared dy dx, right? So again, we took the derivative of something with y in it, so we need to put dy dx. Now on the right-hand side, we have 5y squared, so the derivative is 10y dy dx. Derivative of 3y is just 3, but again, we need dy dx. And on the right, the next one, plus x squared, the derivative is just 2x, okay? All right, now, looks like I'm gonna run out of space here. I wrote too big. So I'm gonna abbreviate. I'm gonna put the 2x on this side, okay? And I'm gonna put the 9y squared, and I'm gonna subtract 9y squared dy dx. Subtract 9y squared dy dx. Okay. So now we get negative 2x equals 10y dy dx plus 3 dy dx minus 9y squared dy dx. Okay. All right, so if I were to factor dy dx out of all these terms, and yeah, I'm definitely out of space here. So I have dy dx factored out times 10y plus 3 minus 9y squared equals negative 2x. And if I divide both sides by 10y plus 3 minus 9y squared, right, what I'm going to get as my answer over here is, I should have kept yellow, negative 2x divided by 10y minus 3 minus 9y squared equals dy dx. Okay? And that's the same answer that they got here. All the signs are changed, though. Okay? But same idea. So dy dx we solved, and now we're done. Okay? All right, there was one more example for you to do. Okay? Maybe I'll have you solve for dy dx. So, yeah, you can do this one on paper and put it in the Ed puzzle. Oh, and there's the answer. Okay, well, never mind. There's the answer, so I don't have to worry about it. Okay, so the last thing we want to do is we can use implicit differentiation, and then after that we can plug in a number, right? So if they give us a point, then we can plug in x and y for our answer. So if we want to find dy dx at a point, all we have to do is find dy dx, then plug in the numbers. So again, I'm going to take the derivative, okay? So the derivative here is 9x minus 10y dy dx equals negative 2 dy dx, and the derivative of negative 3 is 0, okay? So what you can do now is add 10y dy dx to both sides. So I get 9x equals negative 2 dy dx plus 10y dy dx. Factor out dy dx. Then I divide both sides, so I get 9x over negative 2 plus 10y equals dy dx. And now I need to plug in. So x is 4, so that means on the top I have 36. And on the bottom, y is negative 3, so I have negative 32. Okay. That's equal to dy dx. Okay. So if I divide those both by 4, I have negative 9 over 8. So we can get a number. Okay, they got negative 3/4. Okay, so I screwed up somewhere. All right, now. Good learning curve. Oh, I know what I did. I put 9x. That should be 6x. Womp womp. Okay, well. You live and you learn. So, negative 3/4. Okay. So again, the derivative is a number, right? Which is what we've been doing. You know, we can plug back in and get a number. You know, really we do want a number for the derivative if we can. Okay. All right, so this last one I'm gonna let you do on your own, okay? And yeah, but that's the basic idea, right? The basic idea is find a derivative, solve for dy dx, okay? Or take the derivative of everything, then solve for dy dx, and if possible, plug in for x and y at the end, okay? All right.